I have selected the topic of discussion is the design of reciprocating pump. This is very interesting topic. Through the design of reciprocating pump, we will able to find out the speed of the crankshaft and piston diameter. So let's start how to design the reciprocating pump. Before that, let's understand what is a single acting cylinder and double acting cylinder. In single acting cylinder, we have one suction valve installed at inlet and one discharge valve installed at outlet. In double acting, two suction valves are installed at inlet and two discharge valves installed at outlet. Double acting cylinder, in double acting cylinder, mass handled by this arrangement or double acting cylinder is double of single acting cylinder. This is the simplified form of PV diagram where pressure measurement are installed closer to cylinder, that is inlet pressure is installed to the closer to inlet of cylinder and discharge pressure measurement is installed on discharge side of cylinder. So when you say inlet pressure and outlet pressure, it consider it or it takes care of all the pressure losses in the pipe for suction and discharge side. So only left out pressure are pressure drop across the suction valves and pressure drop across the discharge valves. So in PB diagram, you can see this x-axis is volume and y-axis is pressure, and one is the P1 is the inlet pressure, which is closer to cylinder and which takes care of all the losses including the required pressure. Similarly, P2 is the discharge side pressure which takes care of all the losses and required pressure is P2. So now the gap or drop P1 and P1 dash is the pressure drop across the suction valve, and P2 and P2 dash are the pressure drop across the discharge valves. So PV diagram looks like this, and VL is the stroke volume, V2 we can call is a clearance volume. So stroke volume is V1, sorry VL, not V1, VL. So piston moves from 1 dash to 3 dash in one stroke, and corresponding volume is called the stroke volume, which is expressed as VL is equal to V1 minus V2. A stroke length L, is double the crank radius. So stroke length will be L is equal to 2 into crankshaft radius. And clearance volume is the volume of the trap fluid, and it is located at we call it is a V2 also, we call it V2. And so VC, that is clearance volume, is equal to V2 in this case. Now, as far the design is concerned, we need to find out the speed of the crankshaft. This is one criteria for design. So speed of crankshaft is decided based on the allowable piston speed or average allowable piston speed, and there is a relationship among the piston speed, crankshaft radius, and stroke length. The stroke length is a double of crank radius, and the speed of the crankshaft is calculated based on the below correlation. So average piston speed is expressed as Vp is equal to 2 into L into N upon 60. So crankshaft speed with N is equal to Vp into 60 upon bracket start 2 into L bracket close, where N is the speed of crankshaft in RPM, Vp is a piston speed meter per second, and L is a stroke length. So through which we can find out the crankshaft radius, or sorry, crankshaft speed using this equation. So this is one criteria through which we can calculate crankshaft speed based on the required VP, that is a piston speed based on the stroke length. Now the second point is find out the diameter of the piston. So how we can find out the diameter of the piston? So for that, first of all, we need to find out the inlet actual flow. So mass flow rate is given as m kg per hour. Let's say density of fluid is RD kg per meter cube. So inlet actual flow rate inside the cylinder, we can write VA is equal to mass upon bracket star RD, that is density, into 3600 to convert in second. So the unit will be meter cube per second. So stroke volume will be inlet actual volume, that is this, divided by volumetric efficiency. So this will give the stroke volume. So once the stroke volume is known, now we need to find out piston diameter, that is dP. So there is a relationship among the stroke volume, piston diameter, stroke length, and speed of the crankshaft, and for single and double acting cylinder, which is expressed as piston diameter is calculated from this formula. So what is the stroke volume? VL is equal to pi by 4 into dP square into L into N upon 60 into kept small n. So through which we can calculate piston diameter dP is equal to square root of VL into 60 into 4 divided by bracket start pi into L into capital N into small n bracket close. So where dP is the piston bore diameter or piston diameter in meter, L is a stroke length in meter, N is the speed of the crankshaft in RPM, a small n is equal to 1 for single acting and 2 for the double acting. So through using this equation we can find out the piston diameter. So we can say that the design of reciprocating pump is to find out the speed of the crankshaft and the diameter of the piston. So hope you like this. Thank you. Thank you for watching.